Thank you very much. Welcome, everybody, and thank you for joining this session. I am excited to talk to you today about research I've done recently in the area of explicit systematic mathematics vocabulary instruction for students in middle school. Hello, I see some folks saying hello in chat. One of the things that I would love and would help me kind of know how to speak to you as I go through my slides is to know more about your roles in education. So if you don't mind just typing in the chat really quickly what your role is in education, I would love to know that about you. Policy administrator, instructional coach, teachers at lots of different levels, special education, general education, school psych. Awesome. Curriculum coordinators, special ed directors, life skills, tutor, very cool. All right, awesome. So it seems like we have a wide range of folks in education here. I love that. I myself kind of have broader experience in education. I feel like I am a dual certified special education and general education teacher. In my career, I taught in a K-5 resource room. I also taught middle school humanities for a while, so I've worked in special education and general education settings. I spent time as an instructional coach, and in my role as an instructional coach, I was part of a very unique partnership between one of our local universities doing teacher prep and also the district. And so I was coaching pre-service and in-service and paraeducators, pre-service and in-service teachers and paraeducators on their implementation of explicit instruction or direct instruction programs. So if you're familiar with programs like Reading Mastery, Corrective Reading, Connecting Math Concepts, Corrective Math, those types of programs and interventions. And so that was really cool because I got to work with people who were kind of in their practica and their student teaching, but also teachers who were hired by the district and in that role. So that's a bit of my experience. Currently, I am a assistant professor at Utah State University in the special education and rehabilitation counseling department. And so because of my kind of background in education and my interest in both general education and special education, I kind of tend to occupy this space in education where I'm really interested in kind of students. We say mild, moderate disabilities here in Utah. You might use a different term, but also the students who are just struggling or just have learning difficulties or might be at risk. Those might be other terms that people use. Kind of that space right there, and sort of what work can we do to prevent students from falling farther behind, and also what work can we do to close the gap for students who are behind their typically developing peers. And so I see I have a chat message with a question about the assessment group that came directly to me. If you could share that with everybody, then Melissa will be able to answer and help you with that. I don't have the answer to that one. So that's a little bit about me. Feel free as we're going throughout these slides to throw any questions you might have in the chat. I will do my best to catch them. And Melissa is also watching the chat, so if I miss something, she'll pop in and interrupt and make sure we address that question. There'll also be some time at the end for questions, so if we miss something in the chat at that time, you'll be able to pop in and ask that question as well. All right, so let's get into it. My interest in mathematics vocabulary came from that time when I was working as an instructional coach in an urban school district. Students, had lots of cultural and linguistic diversity in that district. It was a lot of the families in that district were families with a lower income background. And so we were doing some work with MTSS in mathematics. And one of the questions that came up was, how do we work on mathematics vocabulary? There was increasing awareness of the importance of language in mathematics and how to teach mathematics vocabulary specifically. And so teachers in this big session we were with were asking this question about, how do we teach mathematics vocabulary? Because it's not in our core mathematics program nearly as much as we would like it to be. So some different suggestions were thrown out there. And later, as I worked on this project more, I kind of did some research on some of these suggestions. But some of the suggestions that were thrown out there in that PD were just providing definitions to the students, either dictionary definitions or student-friendly kind of teacher-created definitions, or maybe even student-created definitions. using flashcards with definitions for practicing. Frayer models, if you're not familiar with a Frayer model, that is kind of a conceptual model with student-friendly definitions and examples and non-examples and different features to help students kind of grasp the definition of something. And so these suggestions in this professional development session that I was in were good suggestions. I don't think there's any problems with those suggestions, except that I was thinking through the amount of instructional time that some of those suggestions would take. The Frayer models, for example, can take like 20 minutes or more of instructional time. And it takes a lot of instructional time. And then there's not a built-in system for making sure that the students are getting review systematically over time either. And so I was thinking about this, and I was wondering if we could create something that was relatively quick and easy for teachers to implement, required little teacher planning time, and also provided plenty of practice and review for the students, and would improve the students' mathematics vocabulary. So all of this got me thinking about, is it possible to create something that the teachers can use and would be easy for them to use and not take a lot of instructional time? And then really important to me, would have that built-in kind of review over time for them. And a lot of these approaches here that are in this list do have evidence of effectiveness in the research behind them. And so it's not like they're ineffective things that people are doing or are being suggested, but they just maybe are not the most efficient, or maybe especially with like student created definitions, they could lead to problems where students are building definitions or coming up with their own ideas about mathematics vocabulary that isn't the most accurate and would lead to problems later. Okay, so just a little bit about mathematics vocabulary and how we believe it feeds into overall mathematics achievement. I think we all know that a lot of students in the United States are not proficient in mathematics. 59% of fourth grade students in the US did not score at the proficient level on the NAEP assessment in 2019. And then only about 7% of students with disabilities were proficient in the 8th grade on the NAEP assessment in 2019. So we know students are struggling mathematically, and we all want to find ways to help them improve. And this little inverted triangle, we love triangles in education, right? This inverted triangle is meant to give the sense that mathematics achievement is this broad idea, and there's different components of mathematics achievement. And one of those components is mathematics language. And there are lots of different facets of mathematics language. One of those facets of mathematics language is mathematics vocabulary. And so by focusing on mathematics vocabulary, we're hoping to improve students' mathematics language understanding and access and use, and then lead to greater mathematics achievement. So some early ideas for this mathematics vocabulary intervention, and these ideas came from talking with a local district here in Utah about what they might find helpful. And so based on their suggestions, they wanted something that would be supplemental to the core mathematics program, something that they could use in general education, and something that they could do like in the fall of fourth grade, kind of as like a booster to make sure the students had everything they needed from K through third grade. And then sort of do this like booster session of supplemental instruction in the beginning of fourth grade to set them up to be successful mathematically from there and beyond. And they wanted something that employed explicit and systematic instruction. So the initial goals when we started writing this intervention, I had a team that I worked with that I'll tell you more about later. So when I'm using we, I'm referring to my team. We wanted to bring students to mastery on the vocabulary necessary for fourth grade and beyond, because we believe that this will improve access to and understanding of mathematics instruction, and that it will increase participation in mathematics instruction and activities, which will lead to improved mathematics achievement. So we started working on this, and we did what we're calling a pre-pilot, and we're calling it a pre-pilot kind of test of the intervention because the intervention wasn't near completed yet, but we had enough of it drafted that we wanted to test to make sure we were on the right track, and that this was going to work before we, wasted teachers and students' time with it. So this was in the midst of COVID, very fun trying to do this project in the middle of COVID. We were able to partner with one school in 4 classrooms. And we ended up partnering, those 4 classrooms were grades 2 through 5. And you'll recall that I said this intervention was developed with fourth grade in mind, with feedback from a local district that we were talking to. Because of COVID, that local district wasn't able to work with us at this stage of the project, but a different school was. But in that school, we had grades 2 through 5 available to us. So we ended up with 80 students. And we kind of were targeting at this point in time, like end of third grade, beginning of fourth grade mathematics vocabulary. These were general education classrooms with students with and without disabilities in those classrooms. And we tested the lessons. We had the teachers implement in grades 2, 4, and 5. So the teachers taught the lessons that we had developed at this time. And because it was developed for fourth grade, but we had second grade involved and fourth and fifth grade, we selected grade appropriate content for each of the grades. So nobody at this time received the full intervention. Second grade received portions of the intervention that were done and that were appropriate for second grade. So things like early fraction, kind of knowledge, concepts, vocabulary, greater than, less than, or examples of things that we taught them. And then fourth and fifth grade largely focused on geometry vocabulary. So shape words, line, angle, right angle, things like that. And the teachers taught the lessons to their students. We were in-person instruction here in Utah at the time. So the teachers taught those lessons to the students, but the researchers were not allowed in the school because of COVID. So we signed in via Zoom every single day and did observations of the teachers and how they taught those lessons. Third grade was a little bit different because third grade very closely matched the content that we were developing at that time. I actually taught via Zoom to the class of third graders all of the introductory exercises for each word throughout the program. So we had about 22 lessons worth of introductory exercises that I taught. And the reason we did that was because those introductory exercises, when you're first introducing a word and its definition and the examples and non-examples, that's a critical time for building student understanding correctly. And if we ran into any issues, we wanted to make sure that we could adjust. And me being the first author of the program, I was in the best position to be able to make those adjustments at that time and kind of play with that and know how we needed to revise those lessons afterwards. So I was at home teaching via Zoom to all these students who were in their classroom with their teacher. And then we collected daily feedback from the teachers via a really short survey. We basically asked, what did you like? What did you not like? What would you recommend changing? And then every fifth lesson, we, turned on our audio and our video, and we asked the students what they thought about the lessons. And we got feedback from them, and we made adjustments as needed based on the feedback from the students as well. We attempted to gain some quantitative data on the effects of sort of this draft of the intervention using a mathematics vocabulary assessment for third grade by Powell. And that assessment from the pre to the post actually showed that we had gains for each class. And we were particularly happy about the gains for the third grade class because that was where we had taught almost exclusively just introductory exercises or lessons without any review follow-up for the students. And so just the introductory lessons seemed to show that we were on the right track and that this instruction was going to be powerful for teaching mathematics vocabulary. So we were excited about those results in particular. So from there, we moved on to drafting and writing the program, the intervention. We're calling it Mathematics Vocabulary for fourth grade. It ended up being over 40 concepts taught across 22 lessons. And some of the strands of mathematics that are included in the intervention are operations, fractions, measurement, geometry, and other strands. It's inspired by instructional design principles outlined by Engelman and Carnine. We are also really inspired by Archer and Hughes' work on explicit instruction. And so if you're familiar with explicit instruction, or if you've used any direct instruction programs like Reading Mastery or Corrective Math, this would feel very familiar to you. It's scripted, explicit, systematic. The sequencing of examples and non-examples was very carefully controlled so that we could help the students understand kind of like the boundaries of each vocabulary word that we were teaching them and when it applies and when it doesn't. We were very systematic about providing mass and distributed practice and also gradually reducing the scaffolding. So on the next slide, I'll kind of show you how we approach that reduction of scaffolding. And I'll also talk about how we achieved that mass and distributed practice. So if you're not familiar with those terms, mass practice is when you give a lot of practice for students when you initially introduce and teach something. And then distributed practice is practice that occurs over time to help students continue to practice that skill or that knowledge and develop mastery in that area, and then continue to review that so that they don't forget it, they don't lose it. We really wanted to make sure we had high levels of student engagement in this program, and so we employed a lot of group unison and individual responding. For the sake of time and efficiency, we did not include any writing activities for the students in this intervention. It is all visuals that are presented to the students, and then the students respond in group unison or choral responses together as a class. Or sometimes students are asked individual questions that don't lend themselves to a group or a choral response. So things like, how do you know, or why would it be like that? Kind of those, some of those like deeper thinking, reasoning questions where it wouldn't work to have a group response because everybody's going to say something a little bit differently. But this was all oral as far as the student responding during the intervention. And it was designed to be taught in fewer than 15 minutes a day. You'll remember earlier we heard from teachers that they really wanted something that was supplemental. And so we thought if we can get something that's fewer than 15 minutes a day, that's pretty quick and easy and still allows the teachers to do what they need to do with their core mathematics program. So we took a modular approach to designing the lessons for this intervention. And what that means is we designed the instruction for each word that we were going to include in the program first. And then we figured out how to take all of the different exercises that go along with teaching and reviewing that word and putting them together into each of the lessons for the program. So this visual right here is meant to illustrate kind of the journey a word takes over the first few days of instruction and then how it's folded into distributed or ongoing practice. So the first day that we would introduce a word, we would provide a student-friendly definition of that word. We would provide many examples and non-examples to go along with that word. And then we would have the students practice discriminating between examples and non-examples with that word. There was a high amount of scaffolding at this point. So lots of teacher prompting, lots of teacher questions to help the students apply the definition that we taught them to the word and make sure that they were applying it appropriately and using it appropriately. So day 2, then we started peeling away scaffolding right away. We reviewed the teacher provided definition and continued to provide that practice with discriminating between examples and non-examples. Day 3, we removed more scaffolding and we also just went right into practice with the application of the word. And then day 4, if there was any scaffolding left in how we presented the instruction around that word, we took that away and we continued to have the students practice applying the word. And then once we got to day 5 of that word being taught in the program, all the scaffoldings were removed. This now went into ongoing, just like review phase. And once it was in review, it was often incorporated into the exercises for other words. So this allowed us to be very efficient and to get lots of practice, lots of review in for all of our words because we took advantage of the relations between words in mathematics. And then we made sure that every word showed up at least every 4th day once it was in that distributed practice so that the students continue to get that review, get that practice, build that mastery. Usually, because of taking advantage of those relations between mathematical concepts, the words showed up more frequently than every 4th day. But if that didn't happen, every 4th day was our bare minimum that we wanted a word to show up. Now, one of the interesting things I thought that happened was that we initially had twice as much time that we used to remove the scaffolding. So when we first drafted the intervention before that pre-pilot, day 1 and day 2 would have looked the same as day 1 does on this visual. So still lots of scaffolding, still defining the word, still all this practice. And then day 2 was the same. And then day 3 looked the same as day 2 looks on this visual. Day, what would that be? Day 4, day 5, and 6 would look the same as day 3. Day 7 and 8 would look the same as day 4. And in the pre-pilot, we had lots of students who said, oh, and I see there's a question in the chat, so I'll get that in just a second. In the pre-pilot, the students and the teachers said, this is way too much time to remove the scaffolding and it's too slow. All of our students could go faster. And so we peeled that all away and we compressed the removal of the scaffolding down into these 4 days like you see here on this visual. So that was something that was surprising to me, but we were happy to be able to go with that because that just means the students could learn more in less time. So we have a question: up to how many words were introduced on day one? Sometimes we had 4 or more words that were introduced on day one. We tried not to go like too many above 4 because we really wanted to be careful that we weren't overloading the students with new information, but especially at the beginning of the program when there's not much time to review yet because they haven't been taught much vocabulary yet, you do have to introduce a number of words. And so we were really careful in choosing which words we introduced. We didn't want to introduce 2 words together that the students could possibly get confused about. So we would not introduce 2 two-dimensional shape words in the same lesson, for example. We would separate that. And we were just careful about what might cause student confusion and how to sequence the introduction of our words to make sure that we were avoiding that student confusion. But sometimes it ended up being like about 4 words per day that we were introducing. And we would not introduce all the words in one exercise in a lesson together. So it would not be like, here are your 4 new words, and I'm telling you all of them right now. If we were doing an exercise on geometry words, maybe we're introducing polygon as the new word in that exercise, but then we're also reviewing some other words related to geometry. And then if we were introducing a new fraction word, then maybe that would be in an exercise that was devoted to fractions and was also part of reviewing the other fraction words. And so the new words were introduced in their appropriate exercises with their related words during the lesson. Hopefully that helps answer that question. Thank you for asking. Okay, so this visual is kind of how once we had developed the instruction for each word, then we needed to figure out how to take all those exercises across all those days and put them together to make the lessons. So this is related to what I was just explaining about how these words and their instruction came together to form a lesson. So at the top here with these boxes, in one lesson, we might be introducing new word, which is word number 23 in our sequence. And there's a high level of scaffolding for introducing that word. Now, in that lesson, we're also reviewing word number 8, which was introduced quite a while ago. It has low to no scaffolding at this point in time. We're also reviewing word number 22 in our sequence, which was just introduced yesterday. So it still has a high level of scaffolding, but it's not being newly introduced now. It's already kind of moving into that review and removal of scaffolding phase. And then we're also reviewing word number 16, and that word might have a medium level of scaffolding to low level of scaffolding, right? We're peeling that away. We're in the review phase with that. And then we're also reviewing word number 2, which was introduced way at the beginning of the program. No more scaffolding for that. That's just in that like cumulative distributed review that we talked about. So all of these different components sort of came together in this funnel that you see here, and that ended up being one lesson. We were able, like I said, to take advantage of the relations between mathematical concepts to help make our instruction really efficient. So for example, new word 23 in this lesson might be polygon. Review word 16 might be quadrilateral. Review word 8 might be parallelogram. And review word 2 might be rhombus. So in teaching polygon, we're also able to review parallelogram, quadrilateral, and rhombus because these are all types of polygons, right? A rhombus is a type of parallelogram, a parallelogram is a type of quadrilateral, and a quadrilateral is a type of polygon. So as we're teaching polygon, we can review and use parallelogram, quadrilateral, rhombuses as examples of a polygon. And so that helped make our instruction super efficient and also made explicit those relations between the mathematical concepts for the students. Now, like I said before, there were lots of different strands of mathematics involved in this program. It's not just geometry, but this is a great example using geometry words of how these things were interconnected and could make our instruction efficient. I spent a bit of time talking about this last slide and this slide as well, because this is what we did to create our program, but I think this is also relevant and useful for folks who are in the classroom or who are coaching people in the classroom to be able to take a similar approach to looking at whatever mathematics programs that you are using and kind of taking this approach and thinking about how can we make vocabulary instruction more explicit in our mathematics programs? And then how can we make sure that we have the review built in so that the students keep using these words and they reach and then maintain their mastery? So instructional delivery for this program, all the instructors, the teachers who were a part of this had a manual with scripted lessons. We did use scripted lessons. My philosophy is not that people have to read these lessons word for word. I want them to put their personality into it and to reasonably adhere to the scripting of the lessons. It's meant to be an aid and a support to the teachers to make their lives easier, not this thing that they're bound and kind of like imprisoned to, right? So they were scripted lessons, but we encouraged them to include their personality and as they needed to, like adjust the language. All of the visuals for each lesson were delivered using Google Slides. And so as the teachers were going through the scripted lesson, they were showing visuals that were related to each of these mathematics vocabulary words on a Google slide deck for their students. And then students responded orally, like I said, lots of group unison responses, individual responses, and we designed the intervention to prompt 7 unison group or choral responses per minute. So we wanted students to be really actively involved and we wanted to get a lot done with little instructional time. We taught the teachers in the study that we ended up doing a general error correction procedure, and that's included in the program, called model test, delayed test. And basically what this means is as soon as students make an error, stop the instruction, tell them what the correct answer is, ask them the question that they just made the error on, so repeat it, that's the test. If they say it correctly, then you know that they heard what you just said. Now you have to go back later, and this is the delayed test, and ask them the same item again, because that really makes sure if the correction stuck, right? If you just do the model and the test, you know that they heard you, but you don't know if that really changed their understanding. So the delayed test helps you know that. And if they make the same error on the delayed test, then you know that you need to provide initial or additional instruction to help the students understand. So this model test, delayed test is something that you can take and you can use across different areas of your instruction. If you're a teacher or if you're somebody coaching teachers, this is really effective and a great way to just make sure that we're addressing errors every time they happen. This is a powerful addition to your teaching if you're not already doing that. Okay, so once the intervention was developed, we wanted to test it to see if it was effective. So we basically asked these 3 research questions, which are, what are the effects of the intervention? Will it work? Number 2 basically was, can it be done? Can teachers teach this? And then 3 was, what will they think of it if they do teach it? So like I said, this was all happening during COVID. We had lots of stops and starts with schools that were interested, and then higher administration said, no, we're not adding an additional thing because of COVID, and I understand. And it was very tricky for a while there, but we ended up partnering with a private school for students with learning difficulties and disabilities in an urban setting in the Pacific Northwest. And this school is known for making data-driven instructional decisions, using flexible instructional groups, not assigning students to just age-based classes. They use research-based instructional programs throughout the day for all areas. And they're a little bit unique. They have a model that's really inspired by applied behavior analysis. So within that school, the administrator requested that we work with 3 middle school mathematics classrooms of 10 to 12 students each. The administration felt that the content of the mathematics vocabulary program we created was most appropriate for the students at the middle school level because they're behind their typically developing peers. So they felt like this was really instructionally relevant content for them. So we adhered to that request. Even though we developed it with 4th grade in mind, we were happy to test it with middle schoolers. Typical mathematics instruction at the school looked like 70 to 90 minutes of core mathematics instruction per day. They were using Singapore primary math and also school-created fluency and fact materials. Some supplemental resources they were using included Spring Math, key books, and essentials for algebra. We asked the teachers prior to having them teach the mathematics vocabulary program how much time they were spending explicitly teaching mathematics vocabulary each week, and they responded with a range of anywhere from I'm not to 25 minutes per week. So these three teachers had a range of years of experience, 0 to 19. Two reported as being female, one male, and two reported bachelor's degrees, and one had a master's degree. All of the students assigned to each of the participating teachers' classes were invited to participate. So that was 32 students who could have participated in the study of the program. 30 agreed to participate. And they were all 11 to 14 years old, and they all had documented learning difficulties and/or disabilities. So this is a visual to show kind of what the study looked like, how the study went, different activities that took place in the study. So this teacher social validity survey number 1 was a survey where we asked the teachers what mathematics instruction looked like, how they were teaching mathematics vocabulary, how much time they were devoting to it, did they think that mathematics vocabulary was important, that kind of thing. Then we worked with the school to randomly assign students to treatment and control conditions. And then we gave all of the students a mathematics achievement test. And this mathematics achievement test at this point was to make sure that the two groups of students were comparable to each other. We didn't want students in the treatment group to be way higher performers or way lower performers than the control group. We wanted them to be similar. So we used that test to help us make sure that that had happened. And then mathematics vocabulary test number 1, this was a test that we also used to make sure the two groups were similar, but also this was our pretest or our baseline to compare the post-test after the intervention with. So after giving both of those tests, we had the teachers teach the program to their students. So all of the students assigned to the treatment condition stayed in the classroom and they received the mathematics vocabulary intervention that we designed. All of the students assigned to the control condition, they went out and they engaged in alternative mathematics activities. So these were like fluency building activities, working on math facts, working on measurement and data. They were mathematics activities, but not mathematics vocabulary specifically. So after the course of the mathematics vocabulary intervention, we gave all of the students that mathematics vocabulary post-test, and that allowed us to compare to see what the effects of the intervention were on the mathematics vocabulary of the students assigned to the treatment condition. And then after that, we sent another survey to the teachers, and this was to see kind of what they thought about the intervention. Was it useful? Did it meet your needs? How do you think your students thought about it? Things like that. So for that mathematics achievement pretest that we did before the intervention, we used Easy CBM Proficient Math 4 Winter. That's a curriculum-based measure out of University of Oregon that assesses general mathematics achievement. To test mathematics vocabulary at pre and post test, we used Mathematics Vocabulary 3rd grade by Powell. This is one of the only mathematics vocabulary tests we could find that has any research validation behind it. And the 3rd grade is closest in instructional content and level to the intervention itself. So that's why we chose to use that assessment. We did monitor teachers' implementation fidelity using an observation sheet that we created, and we did 6 observations per teacher. This was still during COVID, but at this time during COVID, we were actually allowed to go into the classroom and have masks and temperature checks and be vaccinated and all that kind of stuff. But we were allowed to go into the classroom. So those observations were all conducted in person of each of those teachers. And then the social validity surveys I mentioned before and after the intervention were surveys that we created and sent out. Okay, so results. We'll look at implementation first. So this graph shows the time to teach each observed lesson. You'll recall that we designed the intervention for the lessons to be taught in 15 minutes or less each lesson. And these bars show teacher A, teacher B, and teacher C, and then the green is the mean of all of the teachers. This line is a little bit darker right here at 15 minutes because that's what we designed each lesson to be taught within. And so you can see that the teachers were mostly able to teach the lessons in fewer than 15 minutes. Our range of means was from almost 9 minutes to a little over 15 minutes. You do see on lesson 6 and lesson 8 that we had some teachers who were above that 15-minute line. We knew when we designed the lessons that lessons 6, 7, 8, and 9 were pretty heavy with content. and that they were going to be kind of the hardest lessons in the program, just the way that different words converged and had to be taught to protect our sequence so that we weren't confusing students or overwhelming students. So we were able to observe lessons 6 and 8 and talk to the teachers, and they were like, 20 minutes, it's fine. You know, it's just 1 or 2 of the days here or there. It's not a big deal. So even though it exceeded our 15-minute mark, the teachers didn't seem to be too bothered by it. This shows the student scripted response rate. We designed the lessons to have 7 student responses per minute. We wanted the students really actively involved and engaged, and we ended up with a mean of 6.8 scripted student responses per minute, so very close to what we had intended. Our range of means was a little over 6 to just under 9. And you can see on this graph that once we get to lesson 17, the number of student scripted responses per minute goes up really quickly. And that's because lesson 17 on is almost exclusively just review of previously taught words. And so the students were able to do a lot of responses per minute because it was review and they were just going really fast. They had mastered the content and this was quick and easy for them. But even throughout here, we have lots of student involvement throughout the lessons. Okay, these are results off of our observations, kind of our fidelity sheets that we were keeping track of. And all of the teachers taught 1 lesson a day from January 12th to February 14th of 2022, just last year. The lesson component category is the teachers presenting all the exercises, visuals, and items, reasonably adhering to the script. You can see we had high levels of fidelity there. Student responses were obtaining those group or choral responses as directed and using a signal to obtain those responses. A signal is some kind of gesture indicator that it's time for the students to respond. It could be a snap, it could be kind of a hand wave. Teachers have different styles of doing them. It's important to use a signal when you're doing choral or group responding to make sure all the students are responding together and not copying each other. You lose a lot of the power of your instruction if you don't use a signal for that kind of group or choral response. So that was included in our fidelity. We had high levels of fidelity there too. Error correction procedures, we're using that model test, delayed test, and correcting all errors immediately. That was a lower area, which was very interesting. And then lesson presentation was being prepared to teach, having a comprehensible rate of speech, using expression when you're presenting the lesson, and that had high levels as well. So we'll come back around. I'll say a little bit more about those error correction procedures being lower, but teachers often didn't do the delayed test, or they only did the model and then did the delayed test later. They were just missing little components of that. Okay, so results of the intervention on mathematics vocabulary. So this is what the mathematics achievement pretest looked like for each of the groups before the intervention. So this is when we were comparing to make sure that they were comparable. We have control group in the pink and treatment group in the tealish color. You can see we have more of a spread with our treatment group, but statistically speaking, the 2 groups were comparable in mathematics achievement. Similar for mathematics vocabulary. Pink is the control, the bluish is the treatment, a little bit of different spreading patterns, but statistically speaking, the groups were comparable in mathematics vocabulary before the treatment. This visual shows after the treatment, and you can see that the groups definitely are not comparable here. The control group looks similar to what it looked like previously, but our treatment group in blue is almost maxed out on the assessment. And so this indicates that those students really mastered the material and they were able to demonstrate that on the post-test. We had an effect size of 1.99, which compared to other educational interventions in general and mathematics vocabulary in particular, that is very high. Some of that might be the result of comparing students who received the mathematics vocabulary instruction to students who were doing something else related to mathematics, but not mathematics vocabulary in particular. So it might be a little bit different in the future when we compare 2 different approaches to mathematics vocabulary instruction. But even so, this is very high and pretty remarkable. And this is an important step in this line of research right now, because we needed to demonstrate at this early point, the first, kind of controlled test of the intervention, that it was going to work and be effective and not be a waste of students' and teachers' time, right? So these results were very exciting. This is another way to look at the results. So the treatment group in this figure is over off to the left, and then the control group is over off to the right. And the red dots represent the pre-tests for the students, and the black dots represent the post-test on the mathematics vocabulary pre and post-test. And so you can see, just with the pattern of the dots, that they were pretty comparable to each other, like we saw on the previous screen. And you can see that students in the treatment group all made gains. And this purple line right here represents 95% correct or higher on the post-test. And so you can see the vast majority of the students in the treatment group performed at 95% correct or higher. So 16 of the 17 students in the treatment group made gains, compared to only 18 of 13 in the control group. And then 13 of the 17 students in the treatment group scored greater than 95% on the post-test, and none in the control group did. And you can also see we have much more variable performance in the control group, right? Some people improved, some people did not improve. So that's just another way to see kind of how individual performance went. And then this is looking at the individual performance from pre to post in mathematics vocabulary by teacher for the treatment group only. So this was trying to get a sense of, did the results really depend on an individual teacher? So did one teacher or two teachers have great results and the third teacher did not, and that affected kind of the picture that we got, right? So you can see by teacher, again, we have pretty similar numbers of students who performed at that 95% or higher mark. And all of the students except for one made gains, and this one who did not made a really small decrease. And so again, very similar by teacher, which tells us that the explicit instruction, kind of direct instruction inspired approach that we took, and by manualizing the intervention, we were able to support the teachers to get similar results across their classes, right? It wasn't so teacher dependent as it otherwise might be. So yeah, I see people making fun comments about the results. We were really excited about those results too. And we're excited about what they mean for the students and helping the students to have increased achievement and access to mathematics instruction. So these next few slides, I'll talk about the social validity results. This box right here is just kind of like on the feasibility and the usability of the intervention and the relevance of the lesson content and the amount and type of practice. Teachers were given a survey using a Likert type scale of 1 to 5, 1 being I strongly disagree with that statement, 5 being I strongly agree. So we have high ratings on all of these items. The teachers thought it was usable, met their needs, all that kind of stuff. These two items down here are my students were engaged during the mathematics vocabulary lessons and my students enjoyed the mathematics vocabulary lessons. For number 6 with the engagement, we have a little bit of a lower score, which surprised us because we were like, well, your students were responding like 7 times per minute during the whole like intervention period. You don't think they were engaged? But in the literature on engagement in mathematics, there is a sense that engagement, some teachers might perceive engagement as only meaning that the students are engaged in like problem solving activities, not actively involved in the instruction. So there may have just been a different understanding of the word engagement as they were responding. And then 7, my students enjoyed the mathematics vocabulary lessons. This one's harder to interpret because we had one teacher who just didn't respond at all. That one was a little surprising as well, because in our observations of the students, they're middle school students, but we felt like they were enjoying what they were doing. And when we did the pre-pilot with the elementary level students, they were very vocal that they enjoyed the oral responding and having lots of practice, and they felt like that was really helpful. I presented these results at a different conference, and the director of the school that we partnered with to do this study was there, and he piped in and made a comment about how he disagreed with that, and he thought that the students enjoyed it, and he was there watching what was going on, and that was wonderful to hear. So he has a little bit of a different perception on this, but he wasn't one of the ones who was responding to the survey at this time. So I think this calls for a need or highlights a need to have measures to directly involve the students in reporting their enjoyment and their engagement as well. The teacher perceptions are important, but we can also be asking students those questions to gain more insight into that issue. All right, so I want to make sure I'm leaving time for questions, and I think we're getting close to the end, but just a few kind of final thoughts from me. This intervention was effective for improving mathematics vocabulary of students with learning difficulties and disabilities. And teachers were able to implement it with acceptable levels of fidelity with little training. The intervention may be robust to adaptations made by teachers in those error correction procedures. So I came into this feeling like error correction procedures are so important, and we need to make sure that we follow them very specifically. And then the teachers didn't, and we still got these great results. And it kind of made me wonder if we design very clear, well-designed, explicit instruction for our students. It's important to correct errors, but maybe it's not so important that we correct errors in a specific way every single time. So that's just something that needs further research and pondering, but it's possible that we can design really robust explicit instruction, and that kind of is a protective factor against errors maybe. And then teachers found the intervention acceptable, and they all reported that they plan to use it again, and they are still using it this year. So I have a question. Were the teachers given this post survey before they knew the results? No, they were not. Yeah, we did that intentionally to make sure we weren't kind of coloring how they might respond. Good question. All right, another thing I want to add to this slide is that the intervention was all based on oral responses, right? Those group or choral responses, individual oral responses, but the assessment was a written assessment. And so the questions, the prompts, the things that the students had to respond to on the written assessment were very different than what the intervention looked like. But just like the content, the words were very similar, right? So that we can measure. So this oral intervention was able to generalize to a written assessment. And ultimately, we'd want to make sure that the gains we make from an intervention like this are generalizing to general mathematics achievement, but it's promising to see how just working on something orally using an explicit instruction approach can generalize to other ways for students to respond and other kind of questions, forms of questions that they would be asked. Let's see, did you use a certain program that you developed for this vocabulary intervention? Yes. And are the intervention materials available for teachers to implement? We are working on that. I have those. So my team did develop the mathematics vocabulary intervention, and we are working on ways to figure out how to make these available for teachers to implement. And we're continuing to be interested in studying this and the effects of it and kind of doing some further revisions and refinements. So I'll share my contact information later, but if you were interested in partnering with us to conduct research and get these materials and get some training on delivering explicit instruction through this mathematics vocabulary instruction, I would love to hear from you. So I'll share my contact information soon. Okay, some of the limitations to this study, we had a small sample size in a unique setting where the teachers may not represent the typical teacher because of their additional training in applied behavior analysis and kind of their focus on flexible skills grouping that we unfortunately don't always see in the general education or the special education classroom. And then we had a lack of a mathematics achievement outcome measure. It's really hard to measure general mathematics achievement from something targeted like vocabulary. So we're thinking about ways to do that more in the future. Let's see, more questions. Are there resources for the younger elementary grades K through 5? So the program was developed with elementary school in mind, and we implemented with middle schoolers at this school because the administrators felt like that was most instructionally relevant for the students. So this could be very useful for kind of 4th and 5th and 6th grade at the elementary level as well. We're also interested in developing resources for the younger grades too. So that's another thing we'd be interested in partnering with folks with in the future if you're interested. Did this research look into improved math scores in standardized tests or overall math achievement? Yep, it was mainly focused on vocabulary improvement in mathematics. Like I was just saying, moving the needle in mathematics vocabulary is believed to impact language of mathematics, which then is believed to impact mathematics achievement. So it's rather distal from general mathematics achievement. And so we've been thinking about ways that we could measure effects on general mathematics achievement by targeting mathematics vocabulary, but we didn't get there with this study. Great question. Okay, so just some things to kind of summarize what I've said throughout. We designed this for fourth grade, but tested it with middle school. And so we're seeing that this may be beneficial for students beyond the targeted recipient characteristics. Also, it's just more evidence that explicit instruction is beneficial and effective for students across the ages and across different content areas. Also, manualizing an intervention increases the likelihood that teachers will obtain results similar to those obtained during studies. So this just speaks to the importance of manualizing, kind of scripting things down like we did. It also speaks to that slide I showed you where the 3 teachers all had similar results. It wasn't so dependent on one teacher. So having well-designed, explicit, systematic instructional programs and adopting those kind of programs in the school setting can help us to obtain these strong results and make sure that those results are obtainable through, strong implementation across different teachers. It helps kind of alleviate that pressure that's on the individual teacher. And then, like we've said, hopefully recipients of this intervention will benefit from increased access to mathematics instruction and able to participate more, understand more, and apply the mathematics that they're learning in more ways. All right, so this is my team. When I've been saying we, this is who I'm talking about. Dr. Tim Slocum and Dr. Caitlin Bundock, both here at Utah State. Patrick, I can never say his last name right, even though he's a dear friend. Patrick W., I always call him. He is in Michigan now, but he was extremely helpful and worked with me on actually conducting the study. Dr. Peterson is an SLP in Wyoming, and that was really fun to have her perspective on this. And then Pearl and Paul are my 2 kiddos, and they tested many lessons in early forms for me and gave me feedback, which was really valuable for not doing things that were going to be confusing for students. Were the vocabulary words taught in conjunction with instruction in that topic? For example, did you teach vocab dealing with polygons while doing area or perimeter for polygons? No, we did not in our intervention, but I think that that's a very promising way to move forward with this. There's kind of a need when you're trying something for the first time or an early study in a line, and to really test, like, is this going to be effective just for mathematics vocabulary instruction? But I think a way that might be very useful is to then apply what we have learned here to a core mathematics program, where when you are teaching polygons and area and perimeter, you're kind of mixing all those things together, and you can teach that vocabulary more effectively as you're teaching that content. So this ended up really being a remedial intervention in the way that we studied it here, where we were assuming that all the students had already been introduced at some point to all of these things, and we were remediating misunderstandings or building understanding where they just, didn't have it in the first place. But I think a really powerful way to use the knowledge that we're gaining from this is to embed this type of vocabulary instruction into a core mathematics program. That's great. And then what about high school specific maths courses? Yeah, that's another area we've talked about moving with this. I think it would be really impactful to focus on vocabulary necessary for those middle school and high school kind of general education courses for sure, but even courses that involve students with disabilities. And I think, like Adam Scott was saying in his question above, if we could coordinate that with the content, the core instruction that's being delivered, then that makes both pieces of instruction more powerful, I think. Great. Well, I am past the 11 o'clock time, and I know people have been throwing questions into the chat. If anybody has more questions, feel free to throw them in. And I was going to share my contact information. So if you are interested in, partnering to do any research in this area, I would love to hear from you. The slides are available on the conference website. Melissa can give you more information about that. And Diane is asking, did you do any follow-up on the retention of the vocabulary? We did with the school, actually. About 3 months after the end of the intervention, we tested them again. And I haven't finished analyzing that data, I'm so sorry to say, but we were interested in that, and so we did do that. So yeah, feel free to reach out if you have questions or thoughts or are interested in doing research together. I would love to hear from you. And you have the materials from this presentation if those are helpful to you. And yeah, it was great to have you with me during this session today. Thank you so much for your time.